Hello, we are Team 37. My name is Ruri. I am the team leader and my colleagues are Yang, Tao and Afik. We partnered with the ANSCC to build a visual mapping tool. The ANSCC, Alliance of NGOs and CSOs for South-South Cooperation, is a UN-supported organization for networking, knowledge sharing and capacity building for NGOs and CSOs in the developing world. The ANSCC requires a visual mapping tool for displaying their own members' projects. The tool will use IATI data, which can then be replaced later with the ANSCC's members' data. When the tool uses IATI data, it could be used by NGOs and CSOs to understand the types of projects, donors, and locations. They could use this tool to understand the data and create strategies to maximize their impact. CSOs and NGOs often do not have enough time or resources to do fundraising research. Data licensing also needs to be taken into account. Most of the IATI data is open to use and modify, however, some do not, so the tool could keep track of this. We all agree with our partner Matt, who is a Research and Development Officer from the ANSCC, that we have to implement the following key features. The mapping tool should be relatively friendly for people to use. Also, it should support the ability to filter data according to the criteria selected by the user and generate charts to visualize them. We use a JavaScript React framework as the front end and Java Spring Boot for the back end. There are two data sources, the IATI Cloud provided by the IATI Data Store API, which is updated timely, and the ANSCC database, which currently is not available. We have deployed the front end and back end, which is connected to the database onto the Azure Cloud Services. We were previously using Bing Maps API, but instead we decided to use Mapbox because it gives us more control. It supports more advanced drawing features on the map, such as 3D support and more dynamic graphing. As you can see from the diagram, users will interact with the front end of the web app on their devices, which then processes and sends requests to the back end by using RESTful APIs. It will then process the request and extract the data from the source based on the specified request and then return it to the front end, which then displays it accordingly. For our final ANSCC mapping tool, we implemented 5 major features: pin map, top 100 funders, search and filter, search analysis, and the backend API. When a user first opens the site, they are presented with an overview of the data, a map showing the number of projects in different regions. When the user zooms into this map, the regions decrease in size, allowing the user to see how many projects are in each country. In addition, hovering on top of the pins would show the country name associated with the pins. When the user clicks on a country, it opens a page that allows the user to search and analyze the projects in that country. Another overview chart is the top 100 funders. It shows the list of funders with the number of projects they reported. The chart is paginated to display the distribution more clearly. We designed our front end to be easy to use, requiring no instructions on how to use it. However, we thought it would be best to provide a help page to help those who need it. The help page explains how to use the major features of the tool, including step-by-step pictures. Searching is very important when dealing with large data sets. Our search tool allows searching by title and description of activities, and also filtering by country and sector. After a search query is sent, the search results can be viewed and any of the projects can be opened to view a detailed breakdown on their project page. Alternatively, for a search result, the user can click View Analysis, which shows graphs and maps based on the search results. The user can switch the graph type and it will update all the graphs. On the project page, a map displays the location of the activity if it has one. Information is also displayed about the activity overview, budgets, transactions, related activities, and locations. The back end serves data to the front end. The API can be queried to retrieve data sources in JSON format. Also, we have this interactive API document served on the Azure server. It provides descent description, data examples, and use cases which help developers to build the front end. In general, we have successfully designed and implemented both front-end and back-end architectures, which can be the solid foundation for developing the application further and integrating with other ANSCC resources. We have implemented all of the requirements from the Moscow list, which we have demonstrated before. Also, we have deployed them on the Azure web server so that both end developers can inspect thoroughly the performance and efficiency of the prototype.